Good evening, everybody. Thanks for coming out. My name is Matthew Watkins. I'm the chair of the Sustainability Commission here in town and the lead of the Energy Task Force. Kristen is our, she makes everything happen. Thanks for coming out as well, Kristen. I just wanted to acknowledge that we're holding tonight's event on the unceded territories of the Synax people. This is something that I did recently, was just a Coursera course called Indigenous Canada. I think it's like an 8-hour course or something like that. It has a bunch of videos, a bunch of reading content. I found it a great way just to familiarize myself with the issues and just help me be a better citizen towards reconciliation. So something to consider if you have some time. So tonight's talk is part of the Energy Task Force, which is one of 4 task forces held within the Sustainability Commission. We have the Bear Smart Task Force, the Economic Development Task Force, as well as the Food Security Task Force. These are all volunteer-run task forces whose mandate is to help the cities achieve the sustainability goals in these different areas. So yeah, we're volunteer run. We run off volunteer ideas, volunteer energy. So if anybody has any interest in any of these topics and would like to get involved, please don't hesitate to get in touch. We also have a new website up, rosinsustainability.com, where you can find the work of these task forces and the different initiatives they've got going on and learn more about what they're doing. One thing from one of our task forces, the Food Security Task Force has a seed swap coming up on March 8th at Miners Hall. So if any interest in gardening or seed swapping, it's a great event to come out and pick the brains of some local gardening champions that can answer your questions and get you started or refine what you're already up to. So tonight's talk is focusing on local success stories from energy retrofits. We've done a series of these talks in the past that you can find online through our website, covering a lot of the details from air sealing to insulation and covering some of the main concerns and topics about home energy retrofits. And we want tonight to talk to a couple people that have some hands-on experience with retrofits here in Roslyn and hear about their experiences and some of the lessons to be learned, some of the successes that we've seen in our community. So we're joined by Jeff Kirkpatrick, who is an energy advisor and is the energy advisor contracted to do the work on the Roslyn Retrofit Assist program. Jeff has decades of experience in construction and is a very passionate energy advisor. And so we're lucky to have him on the team. And Amber Davis is the Built Environment Initiatives Coordinator with the Community Energy Association. And the Community Energy Association and Amber are responsible for the Retrofit Assist program in Roslyn, which is a huge help to getting people into energy retrofits and getting them through the process of retrofits. So we're going to hear from both of them tonight, and we're going to start with Jeff.
Good evening, all. I appreciate everyone for joining tonight. We'll cover. We'll leave to Amber to go through some of the success stories in relation to the data, which she has great access to the final fit and finish data. I'm primarily the field operative on the ground, seeing the common pitfalls, successes, and potential failures and considerations. So I'm going to cover a bit of the building science again tonight. I know it's a rehash for a lot of the people involved, but it's just, as somebody who's on the ground, I'm still seeing a lot of need to understanding the holistic sense of a house as a system and the critical barriers and functions. I'm going to touch on a few items in regards to what I'm seeing out there and considerations, and highlight some very important considerations for ensuring that that future work, or if you haven't started or completed a project yet, considerations that are critical as far as what I'm seeing as the current state of affairs with the program. You can go ahead, Red, and do the next slide. So key concepts in home energy retrofits. understanding house system, insulation, and air sealing overview. And in that, I'll address some of the common pitfalls. And I need to highlight, obviously, some safety items because there's a number of case studies currently that we want to be ensure that we're addressing items like combustion spillage. So go ahead, Red. So just a recap on obviously Red's previous presentations, but the importance of the concepts of home energy retrofit. The initiatives would be, I want to make the home more thermally efficient and airtight. I want to reduce energy consumption and energy cost, improve thermal comfort and indoor air quality, and avoid causing issues due to retrofits that do not utilize house as a system. The goal is to improve durability, comfort, and life cost performance. This is can be a very sensitive aspect when we're dealing with a residential home and making adjustments. Rosalind has a unique diversity in home construction and timeline. So it creates quite a number of very complex considerations to take into account when we're looking at that entirety of the envelope of the environmental separation. Go ahead, Red. So I'm just going to cover quickly some of the terminology that we're referring to tonight. Building envelope, which is environmental separation, the parts of the building that separate inside conditioned space from outdoor space. That is the critical envelope, and we look at that as a six-sided box. The thermal insulation in R value are materials that resist heat flow, therefore insulates the building, typically measured in R value, with a higher R value meaning more insulation. We're going to delve in a little bit more of that. Air leakage is the uncontrolled airflow through the building envelope through cracks and unintended openings, which is not your known values, such as dryer, bathroom vents, range fans. Air tightness and air barrier are a combination of materials and components that together control airflow through the building envelope. And I'm going to be touching on that in a little more detail as well. Air sealing, which we've had lots of experience with, products, tools, and labor intended to reduce air leakage through the building envelope and improve air tightness, air barrier, which is a critical function of our envelope. Go ahead, Red. Thermal comfort, consistently comfortable and stable temperatures throughout the house under normal operating conditions. Indoor air quality, which for me is a major subject for anybody in an enclosure in a conditioned space. Energy retrofit typically refers to the work to improve the thermal insulation and air barrier in the building envelope, but also includes the mechanical upgrades where applicable. And obviously an attic is a roof structure and void space above the ceiling. Common to BC homes can be a conditioned space for mechanicals. This is a critical option in upgrading our homes, that we can convert those areas to a conditioned space. Below grade are the areas of the building that are mostly underground. Examples are basements and crawl spaces. And above grade are areas above the ground, obviously. Example is walls and roofs. So this slide is going to be very critical. I'm not going to read everything in there, but I just want to highlight that in order for a homeowner or consumer to effectively address their potential upgrades or the considerations for upgrades to their home, whether that's through the TEDI, the thermal energy demand intensity, or your MUI, your mechanical energy intensity. These resources, so keeping the heat in from National Resources Canada is a guide to educate and basic principles of building science and to provide guidance in home retrofit projects. And that'll carry you right from attic to foundation with photos and explanations, giving some of that building science fundamentals, but also highlighting the importance of house as a system, and then obviously safety concerns within that. Great resource to get you started. BC Housing has some excellent areas for resource. The research library is where you're going to find most of those items that I've listed below there. They are the best practices guides developed for a number of applications in this sense, window and door replacement, air sealing and insulation retrofits, the building envelope guide for houses, Part 9 residential construction, which is really a good resource for wall components, wall design, and the building science behind it. A guide for contractors and homeowners, the consumer guide to window and door replacement. Some really good stuff there as far as vetted, consistent information where it's not surfing YouTube and getting a lot of, misinformation. This is vetted. A lot of these guides are written by RDH Building Science, which I'm still a part of on a part-time basis. So a great resource is this list of items on here. The Learning on Demand Acts through BC Housing has some great videos with 1 or 2 CPD credit programs, but also take a deeper dive into mechanical systems, building envelope systems. So great resources. I present this because a lot of this is a necessity in order to understand your renovation upgrade reports once we've had a pre-assessment, in order to make a good decisions around the home, whether they're immediate needs, stretch goals, the life cost time, time frame of the home or your occupancy of the home. Having a good data to build that decision base from is critical in making those decisions around the betterment of our homes. Go ahead, Red. So this is very important from a building science point of view. As an energy advisor, these are the 3 critical metrics that I'm deriving from my time on your site. Your thermal energy demand intensity, which is your TEDI, provides a measure of the amount of energy a building requires to maintain indoor air temperature that is thermally comfortable for occupants per meter of conditioned floor area per year. So a thermal energy demand intensity is your air tightness metrics and your thermal insulation values of your 6-sided box. Your total energy usage intensity is the measure of the building's total energy use, including process and regulated loads per meter of the building area per year. So that when you get a renovation upgrade report and it has a comparative value in gigajoules, that in essence is your TUI. So if you've got your 180 gigajoules per year is your current consumption value, we want to definitely get that down. And your mechanical energy usage intensity provides a measure of the modeled amount of energy used by space and heating, ventilation, and domestic hot water systems per meter of conditioned floor area. So when I look at modifying or improving the performance of a building, I have 2 dials, my thermal energy demand intensity and my mechanical energy. I'm going to address the envelope first wherever possible, and that would be my air tightness metric and my insulation values for my enclosure. So if I can't turn up my TEDI dial, I have to turn up my mechanical dial to compensate, right? So I'm feeding more mechanical energy usage in to compensate for my high level of air leakage or my conductive losses in the building envelope itself. So if I can turn up that TEDI value, I can reduce my mechanical needs. And that's really the function that we're in this process. We currently have by default utilizing more energy than necessary to maintain the conditioned space of our buildings, but also to provide drying potential within that assembly between winter and summer usage. And we'll see that a little bit further in the slides. But a critical function of that is being able to reduce my mechanical usage and turning up that TEDI dial. Go ahead, Red. So the building envelope, and I'm sure we've covered this many times over, but it's really critical. I cover this daily in every interview I go to. And, subsequently what's caught my attention is how much I have to rehash this information with contractors. So all windows, walls, and foundations require the 5 critical barriers. The primary barriers that we're concerned with right now are my air and thermal insulation. Those are my TEDI values. In this diagram that we're looking at, we can see that it is a standard, say, 2x4 wall cavity. My drywall layers on the inside. My air barrier and my vapor retarder are one and the same. That is the poly behind the walls. Now, this would represent a 70s or even 80s building and newer. So anything pre-80s is not going to have effective air and vapor barrier. That's just the nature of our build process, and anything pre-50s is going to be even less critical barriers, and pre-40s, which is pre-building code, is just, the Wild West in building enclosure. But if we want to look at indoor air quality, comfort, and conditioning, all walls for durability require the 5 critical barriers. The water shedding surface is your cladding assembly meant to keep 90% of the water out of the walls. Your water resistant barrier are the layers of membrane behind that, which, in an older home might be the felt papers, newer home polyolefin construction wraps. meant to be your final plane of protection in regards to ingress from the environmental loads, the outside conditions. And then your vapor retarder, by default, generally the poly. In an older home, that would be your craft bats. And then your air barrier. And air is king. The air is the Uber ride for heat, sound, and moisture. So go ahead, Red. We'll get deeper into it. To make the house more thermally efficient, our typical scenario would be a high percentage of air leakage and inefficient heating and cooling. So I need a large, in this case, mechanical means to compensate for the amount of air leakage and the low thermal performance value of my wall assembly. An improved, which is reduce the ACH, or air changes per hour, and add insulation where possible. And I'm reducing that mechanical needs to some degree. An excellent envelope is a good air barrier and extra insulation, which I always refer to as the sweater and windbreaker. Everything in nature puts the control layers on the outside. You and I got up this morning, put our control layers on the outside, and we go outside. We put the sweater and windbreaker on to protect ourselves. Well, our buildings can respond from the same treatment with excellent results. So in this case, I've reduced my air leakage. I've reduced my conductive loss. I have very small mechanical needs, and I have an HRV to give me my fresh air resources for indoor air quality. Go ahead. Yeah. So just air leakage is important in both seasons. So we're losing heat energy through our homes through radiative, convective, and conduction. The conductive losses throughout the home are quite prevalent. I can see that clearly when I go into a home with the thermal camera, and I can see all your stud and framing work. That's a conductive loss. Convective loss is all the air leakage in through the top plates, sill plates, penetrations around the building enclosure, and the radiative through window openings. The same conditioning is happening in the summertime. We require that durable thermal envelope in order to protect us from overheating in the summertime. Go ahead, Red. So just for those that don't know, measuring air tightness is done with the blower door. A quantitative air tightness measurement is a useful starting point to get a number in ACH changes per hour. It's utilized by a calibrated blower door fan, is used to pressurize or depressurize the building and measure the air tightness. Go ahead, Red. So the ACH number indicates the volume of air that can be blown through the envelope under standard test conditions. The high test point that we start at is negative 50 pascals, which would be the equivalent of a 40-kilometer wind blowing on the building. So on the face that is lee to the wind is going to pressurize that side of the building, but as the wind eddies over the building, it's going to depressurize the opposite side of the building. So a 10 ACH building, let's say I have 20,000 cubic feet of interior volume of space. At a 40-kilometer wind event, that means I'm trying to condition or maintain the conditioning of 200,000 cubic feet of air per hour. So for ACH in the bottom example, lower the better. So if we can lower our ACH rating, we're reducing that amount of that required conditioning or the BTU energy to maintain the conditioning within that space. Now, all homes aren't, it's okay, but it's important to note that two houses side by side with the same ACH rating are not comparative values. It is a relationship between volume. So if you have two houses side by side and you're comparing your ACH values and it's, a 2,000 square foot, footprint over a 3,000 square foot footprint, they are not the same ratio of number. It's in relationship to the volume of the space. So here before work begins, house is a system. This is now the critical part of the conversation. By default, older homes may not be very energy efficient, but they usually have built-in risk mitigation. So all of our existing stock homes, a 2x4, 2x6 standard infill insulated framed wall, has the high potential for condensation on the sheathing plane throughout the winter months. So any air leakage, a pressure differential between interior and exterior, laws of physics states that pressure wants to equate and temperature wants to equate. So we always have a little bit more pressure on the inside opposed to outside. Air pressure is always looking for those openings. We hyper-focus on the vapor barrier, but the vapor barrier is a function of coverage. The air barrier is a function of continuity. So if I don't have that continuity in an air barrier plane, whether that's the airtight drywall or through control layers within the wall assembly, I now have a high potential at all those leak locations for wetting or even frosting, generally frosting in our environment here in the Kootenays, within our wall assemblies. The air leakage metric that we have in our leaky existing stock homes is also beneficial it keeps that wetting and drying balance. So when I move into the warmer months, especially when I start getting some of that long wave radiation from the summer sun beating on the walls, I'm drying the walls out. So air leakage and heat loss through the envelope helps dry things out. But if I start making changes to the envelope, I could have critical loading. I upset that wetting and drying balance, and I have conditions of wet, wet, and then dry, where I have sustained wetting, which is food for fungal and mold growth. So it's critical to understand that we can very quickly change the parameters of the function of our building when we're in the process of making changes if we're not looking at the house as a system as that approach. Go ahead, Red. Everything should be considered during retrofit work. We want to have good data to base it on. I want to make sure my foundation's stable, to worthy of investing the time and money and effort in, which is the structure. I want to make sure the mechanical equipment, the direction, is it going to meet my needs? If I do make changes to the building, is mechanical going to happen first or second? And occupants and operation. I see a dramatic change in the operation of a building depending on occupant loading. If we go from, an older couple that sold off the home and a young couple moves in with a couple of kids, and we change that occupant load behaviors, has a dramatic effect on the interior conditioning environment. Energy upgrades do not occur in isolation and may affect several building components, and if not planned well, they can lead to issues in the house. Go ahead, Red. And combustion spillage. So again, we're in these homes where we by default had been using considerable amount of fossil fuel energy or combustion appliances, and we start trying to air seal and reduce the ACH metric. We have a condition that creates that combustion spillage where we create draw to the inside of the building. Air sealing can lead to poor air quality if a good home ventilation is not provided, and improper retrofit work can trap moisture and potentially degrade the structure. A scenario I've recently had was a replacement of all new windows, and those windows, as we can see in that photo in the bottom, started condensating quite excessively. The homeowner assumed that there was something wrong with the window installation, and upon review, the mechanical hadn't hooked up the fresh air return to the furnace, which was just recirculating the interior air and getting excessively high condensation rates within the building. So their RH was well over 70%. It crept up on them unbeknownst, and that was what the issue with now my dew point is so high at 70% and 20 degrees. My dew point is like 15 degrees, so it's gonna condensate on the lowest R value component within that wall assembly. So something as simple as a mechanical not being properly installed was enough to cause condensation in a newer home. Go ahead, Red. So just a visual aspect to show that in an existing, air leakage provides a lot of that combustion air. And as somebody who goes around with a thermal camera and has reviewed everything from an 1870s building to a 2025 building, we can visibly see these locations of air leakage. So anything pre-70s, you're going to have a fairly high ACH rating, and most of that fresh air that you're consuming on the inside of the building is actually coming through the walls. If in the wintertime conditions, when all the windows and doors are closed, your fresh air intake without dedicated intake is coming through your walls and gaps at foundation to floor or ceiling plane. So in this case, we've existed in that natural balance of the building's leaky enough, there's enough air coming and going through the envelope that I'm not at risk of combustion spillage. But as we move to the right with a little bit of air sealing, I'm going to have a potential that when I run the exfiltration components, my bath fans, range fans, and dryer is a big one, sucks a lot of air out of the space. If my envelope is more efficiently sealed, there's a probability of drawing that combustion gas back into the space. So one of the more typical is your gas hot water tank. And if you look on the top, there's a raised hood above the combustion exhaust. And that is an area where if you were to turn on all of those components at once, if you had people in, occupying the bathrooms with the bath fans on and the dryer was on and the range fan was on all at the same time, and I can raise the interior pressure differential by more than 5 pascals, I'm at a risk of combustion spillage. Go ahead, Red. So some of the ways to avoid, obviously, a dedicated combustion air intake. Direct venting with a new appliance, so say a condensing unit, or electric heat appliances with an HRV. In this case, this photo is representing an exterior air source heat pump supplying, but the fresh air intake for that would be, if you were at that level at 2.5 air changes or less for your home, you're going to want to consider an HRV to provide your fresh air. Go ahead, Red. New homes must have continuous ventilation. So this is BCB's building code. Must have a dedicated fresh mechanical ventilation system ducted to each living space and must run continuously during heating season. This is out of the ASHRAE requirements for indoor air quality. It's definitely worth considering for retrofit homes. So this is sort of an example. We're going to run through this example of average R value. It's a critical exercise in understanding the changes that we make to the building and the potential offsetting of costs, but also the effectiveness of those opportunities. So the example here is the existing 1970s rancher. Give it a click, Red. My walls in this case are an R12 craft bat, and there's 1,000 square feet of exterior wall. Our attics are R20 at about 1,200 square feet. My floor is R20 over crawl space at the same 1,200 square feet. And my windows are a single glazed aluminum framed window with an R1 is being generous in this case, and they occupy 125 square feet of that exterior envelope. So my average weighted R value for that wall is 10.8. So this is referred to as your UA, or your U value over your environment as an average weighted value. So obviously my windows are different R value than my walls. So if I was to take all of those components together, my window to wall ratio, the wall component, the R value of the wall, and I get a UA value in this case of R10.8. Go ahead, Red. The windows make up 3% of that envelope, but because of their low R value, they make up 30%, 38% of the heat flow through that envelope. Go ahead. So if I was to add 9 inches of new attic insulation, turning my attic to R50, give it a click, gives me a 12% improvement of the overall R value of the building to R12. Go ahead. I upgrade my windows to an R4 Energy Star standard window, gives me a 39% improvement to R15 for the UA value of the envelope. Go ahead, Red. Now, if I just put in 6 inches of new attic insulation at R40 and the new windows, I get a 58% improvement from my previous R10 to R17. Not bad value if I need to get the place to a comfortable space. This is the first steps in upgrading that envelope. Go ahead, Red. So adding insulation to an opaque assembly, even R30 of new insulation had a relatively small impact at 12%, but improving the windows from R1 standard to R4 had a significant impact on the average R. Combining upgrades, even with less attic insulation, had the biggest impact at 58%. And the concept applies to all assemblies, combination of envelope improvements. Windows and doors are always a good starting point if possible, and upgrading them provides other value like comfort and air tightness. Talk to Amber, you can learn more. Go ahead. So here's some current scenarios that I'm seeing, and I'm leave some room for Amber to talk about success stories. Unfortunately, with our current state with the contractor level, we have some great contractors and we have a pool of less experienced or less capable contractors. We're going to get that in any marketplace. It's critical to understand the function of your specific product and being able to navigate the upgrades effectively. So the thermal camera highlights all of the things that we don't see, out of sight, out of mind. So in the case of the top left photo of the insulated attic space, if I can see the top cords, I definitely don't have enough insulation, right? So if I have a 2x4, in this case, a 2x4 cavity, I've got barely an R8 bat of insulation in that attic space. We would like to see, minimum R30 to R50 in an attic space. The ventilation principle. So what we see in the very center of that photo is an insulation baffle. I want to highlight this because all attics that are an unconditioned attic of this nature require those insulation baffles installed, not as a code requirement, but as a good practice, because one of the critical elements, and we can see in these in the thermal images, the cold at the top of the wall. So my top plates are the most unprotected component of the building envelope. And in order to get insulation all the way out to the eaves and fill that cavity, but I need to maintain my 40% open ratio for attic ventilation, I should have these baffles installed at every second or even each roof cavity vent transition, so that I can ensure that my insulation value is consistent all the way across the assembly right to my eaves and top plate. This is a critical function. I've seen gone back to many post evaluations after retrofit work has been done, and there's potential for frosting all along the top plates. So the top plates are on a horizontal and they're in contact with my exterior elements all the way through to my interior elements. They're a major conductive loss. So in peak periods like this, we're getting the double-digit cold, and I'm trying to maintain my interior conditioning at 20% and or 20 degrees and 40% relative humidity. Those top plates can potentially frost. I've seen it all the way around the perimeter of the interior of the building. So it's a critical area that ensuring insulation continuity throughout the upper plane of your environmental separation, and getting that insulation all the way to the eaves requires the baffles to be installed in order to maintain your ventilation. We can see in the photo below that that's air leakage at the base of the wall. All of these photos are taken under depressurization, so I'm actually pulling air into the building. But a typical conditions is that we're living in a pressurized environment, a half Pascal to 1.5 pascals above in exterior environment pressures. So there's always a little bit of pressure pushing out, especially under heating conditions where the air is buoyant and we're pushing that air. Forced air furnace makes that even higher pressure level. So we're seeing the air leakage at the base of the wall. If we look to the center photo, what we're seeing is the attic insulation didn't get installed all the way to the eave. So we can see into the ceiling plane there that there's some cold spots. Then we also see at the walls that there's channels where there's missing or voided insulation. This would be, say, a in the 1950s, they added insulation. They either blown in or they would drill holes at the top of the walls on the interior, the exterior, and add insulation in. In this case, there was potentially some blockage, horizontal members, switch plates, or plugs in the walls where the insulation hangs up and it doesn't get installed. It doesn't get consistently into the cavity. It was a great solution at the time for these, many homes that didn't have insulation at all. So we needed to add insulation. I had a 1901 in New Westminster prior to this, where they had this case scenario. When I thermoed the walls, it was balloon framed and had blocking throughout the wall assemblies. So I had tons of pockets and voids where there was no insulation in the walls or it had settled. So in this case, we have a complete channel, which creates a very detrimental impact called convective looping within the wall assembly. So as the warm air enters that cavity, rises through the assembly, it cools, deposits the moisture, the cold air drops, and draws more air in and starts a convecting loop process, which just feeds the wall with moisture. So what we're seeing in these photos, some of this can be a moisture accumulations as well. That's the only problem. The camera doesn't tell me between cold, wet, or dry. But unfortunately, it shows me that there's a problem. So we can see on the right-hand side here, there's a very strong cold zone. Obviously, the blue, the yellow is the warmer, and the blue, purples are the colder surfaces. I'm sorry if I didn't explain that first, but in this case, there's a electrical hole drilled through for the electrical run through the top plates. So we have air coming down into the walls. We also have air across the ceiling plane and air leakage at the light fixture itself. So this is another opportunity for convective looping within the wall cavity, but then also that would be a condensing zone up in the attic space as well. So you can see in this wall, you can see the faint outline of studs. They're a little bit yellow vertically, and those are the conductive losses within that assembly. And then we can see all the cold spots within those walls. That's definitely not what we want to see. Go ahead, Red. So we can see here on the left another case scenario, which I think is very interesting and important to highlight, is that in the top left, just beside the focal point there, is an interior beam where a wall was removed, but I have air leakage from the exterior wall into that beam channel, which means that air can now track through my interior walls, which unfortunately makes it very difficult to complete an interior air barrier approach referred to as an airtight drywall approach, and the drywall being the most consistent finish within the home. So I can utilize that consistent plane by finishing it out and sealing penetrations, sealing the drywall to the floors, ensuring that that is sealed to the windows and door penetrations, and pick up some air tightness metrics based on the airtight drywall approach. But unfortunately, I have no control of the air that's moving through all my intermediate walls within the building. Another one here on the right, which is not as uncommon as I expected, but so this is wood fiber infill insulation left over from the mills. So you barely have an R4 ceiling plane. And this is a current conditions within areas like Rossland, where we have historically, poor building practices. Our needs weren't as critical as they are in today's environment. So, this was a normal acceptable practice. To the right of that, I've included this photo because it's interesting in the sense that here's a 1950s application of craft batt insulation. So that paper facer that we see there is actually either two layers of the paper face with an asphaltic layer in behind or in between, or it'll be a one layer with asphaltic layer. It's meant to be early draft proofing, which is what we refer to as air tightness now, but back in the day it was your vapor diffusion. So the asphaltic layers in between created your vapor barrier, and then the insulation obviously is your thermal resistance. In this case, this is a knee wall, so to the left of this wall is conditioned space, and to the right of it is your attic space. So this is your 1.5 story walk up. What's interesting in this photo is they've installed the craft batt backwards, so it was an afterthought. This is a building that wasn't insulated necessarily initially, and in the 50s added the craft batt, but the vapor facer is meant to be facing the inside as your vapor layer. So the craft batt is deteriorating, falling apart because it's an accumulation layer for vapor in this case over the years, and it's degrading and falling out of the walls. Go ahead, Red. So this is too fast. Thanks, Brad. On the left is a newly installed Energy Star door, not tied into the critical barriers of the building. So this is going to be the big theme for me, is regards to the critical continuity of that air barrier assembly. And if I don't have an air barrier assembly, it is mandated, CSA A440, BC Building Code, Best Practices Guide. It's repeatedly highlighted in the HPCN contractor vetting process that you must maintain contact with the critical barriers. If there are no critical barriers within the wall assembly, if an older home with no poly or no water resistant barrier on the outside, you are to install the window so that you can tie into those critical barriers if subsequent work was to be done. This is the requirement of a contractor to install to CSA A440 standards. In this case, here's a new Energy Star door that is simply spray foamed into the opening, and I've got tons of air leakage around the frame, not the hardware or door itself. This is outside of the frame to jam tie-in, which was just done with spray foam. Spray foam is not a continuity tie-in between components. I'll just dive into that one a little bit. Spray foam itself, one, has a long-term thermal resistance loss value. It doesn't maintain its R value over time. It doesn't rack with the building. All of the buildings that we're going to be looking at, within Rossland are organically wood-framed buildings. They respond to the temporal seasons. They respond to wind loading. They respond to occupant behaviors. So the building is organic and moving a little bit in, interstory drift. We get conditions like truss uplift. The building's always moving a little bit. What the spray foam does, being a hard material in there, one, it doesn't have the elongation to transition, though, when the building is moving, but it also transfers the loads of that movement directly to the window or door. And in the case of a window, we specifically do not want to transfer the loads from the framing to the window. The window is meant to be floating in the opening, suspended on shims, so that the building can rack and not affect the window. So the window manufacturers require the window to be, spaced within the opening. New National Building Code is going to move to 3/4 inch space around the windows. Typically, we see a 3/8 to 1/4 inch with some spray foam in there. And all we've done is potentially reduce the lifespan of our window component because we're transferring the loads directly to the window. On the next two photos on the right, this is actually my house, and it's a great example in the sense that what we're seeing here is the siding element on this house is vertical 5/4 round decking. So there will be one piece on a 4-inch space and then another piece capping over that space. And that's why we see this striations of the lines of the vertical elements here, is because what we're seeing through the surface is the sheathing in behind. So I'm conditioning my space on the inside, and in this photo you can see it's -9 on the surface of the wall. It was actually -16 when I took these thermal images. This was last year. So it's -16 out is ambient, but the surface of my wall has got so much conductive loss that the surface of my siding is at -9. And if I was to take the piece off and look at the surface of the wall, the surface of my wall, which should only be a couple of degrees less than the outside ambient air temperature, but it is actually 10 degrees less than the ambient air temperature as a result of the conductive loss of the assembly from the inside. And then we can see on the far right up at the eaves where I'm getting most of that conductive loss because of that horizontal member transmitting that heat energy from the inside. So when I'm heating my indoor space, I'm heating all of the surfaces. We're subject to surface temperature inside the space. All of the components within in the home are going to absorb that heat energy before it's radiated back into my space, back to me within the space. So if I have conductive losses, in this case, drawing heat energy out all the time by default, wherever I can reduce that conductive loss, the better. So in this case alone, I'm doing a deep energy retrofit on my home this year. I'll be stripping off all the siding and exterior air barrier. I'll be putting 4.5 inches of exterior insulation on the outside of the building for that sweater and windbreaker effect. I'll also be doing it to the roof and to the floors on the inside. So I'll be wrapping that sweater and windbreaker around all 6 sides of the building. By my calculations, I'll eliminate cooling needs in the summertime, and I'll reduce my my consumption needs for heating to a very small heat pump in order to meet those heating needs. So it'll be right now, as it is, I heat primarily with wood. That's why I can get it so glowingly hot on the inside of the building. But I wouldn't be able, because of it's only a 1,200 square foot space, but it's 2 stories full, open volume, open concept space inside. So the heating process for that volume of space is quite intense. And I couldn't afford to heat it with mechanical or combustion, whether it be electric or combustion gas appliance. It would be a ludicrous heating venture to try and heat the space. And this is a 2006 home. So by just putting that sweater and windbreaker, I'm going to reduce my heating needs to literally a hairdryer during the winter months, because I already have as a benefit, I already have HRVs installed in the home. So I have fresh air. So I can reduce my air change metric. It is currently at 1.75. For this space, and I'm planning to go beyond passive levels if I can and reduce my air change rate metric to about 0.5 air changes or less. I've built into the past at 0.012 air changes, where the only heat source was recovery through a heat recovery ventilator from the battery storage room for the solar on a remote cabin. Was the only heating source in the middle of winter for that building. So dramatic effects can be made with the envelope first approach. Go ahead, Red. One more. Yeah, air sealing top up priority. Critical first step is the sealing plane, because as we heat in the interior space and it stratifies up through the envelope, it sits against the sealing plane, and that is the most critical area for air sealing intervention immediately. All existing stock homes require that intervention today. All right, go ahead, Dad. So we can see from this plane that we have a ton of penetrations actually within our ceiling plane. We have, duct chases, we have bathroom fans, range fans, pot lights, and then lots of penetrations within our framing assembly as well. So I have wire chases, plumbing chases, going down through, so there's common wet walls, there's electrical feed walls from your panel all the way to your second or third story elements. So lots of opportunities in the ceiling plane is sort of the final cap. If I can get that ceiling plane air seal, so in a retrofit application, I'm not simply adding insulation to my space. And you'll hear in the industry that adding insulation improves air tightness. Well, from a building science point, it's not a good enough answer for me. I would actually go in there, pull the insulation back in these areas. We have some videos giving description. It talks about it in all of the publications referred to earlier in the slide deck on how to air seal all of these penetrations. Really quite simple, not difficult at all. Even a homeowner can take this under themselves and make a dramatic improvement on your losses through the building envelope. Go ahead, Red. So just a little bit closer detail here. The duct penetrations, my proximity to combustibles. So obviously in this top left photo, I'm showing that the insulation is pulled back. I've used a piece of sheet metal to tie into my components because that would be a hot flue vent coming through, same as the one below in the combustion exhaust appliances. So I can use sheet metal and fire sealants to bridge those components so that I can maintain that continuity. We can see here the exhaust fan. That's an XPS, which is your extruded polystyrene. That's your pink or blue insulations. So I can buy a 1/2 inch or even a 1 inch piece of that insulation, cut it into a small box, and air seal that over my penetrations. Perimeters and top plates is a critical transition period for air sealing. That is one of the most leaky areas we saw in those previous thermal camera photos. Recessed pot lights, there are components off the shelf that can be purchased to improve that air sealing process. Attic hatches are the elephant in the room. That is it is considered a door. It is considered a critical opening in your envelope, and we generally have a piece of drywall or a piece of plywood up there. It is a door. It requires insulation, an air sealing gasket, clasps to create compression on those gaskets, and a continuity in the insulation layer above. Critical, easy things that anybody can, low-hanging fruit for improving air tightness are all the elements on this slide right here. Go ahead, Red. So some safety issues, of course. Asbestos, seeing a lot of asbestos and vermiculite in homes in Roslyn, obviously very common. It means I can't do a blower torr test by Intercan standards. Old pipes, still quite a bit of old ducting pipes. The fabric tapes that you'll see on the ducting are as an asbestos tape and need to be remediated. You can use it's called duct seal in a liquid form, and you can paint that over those components if there's just a couple areas that you want to seal up. But generally requires a complete environmental assessment if doing any major work. Any disturbing of those components requires an environmental assessment. Go ahead, Red. Fungal growth, again, attic spaces are one of the worst. I've had a whole series of investigations lately where We get all kinds of scenarios, some called night rain, where the attic rains back down in the spring or fall because of the conductive element through the roof, exposure to night sky radiation, warm attic spaces, that transition at nighttime when night sky radiation starts sucking the heat off the planet. We get a condition called night rain. All of those penetrations that are leaking that conditioned air. So, the occupancy is respiratory is the biggest contributor to moisture within our spaces. Ideally, we want to be in that 37 to 57% range as far as ASHRAE requirements for indoor air quality. We, family of fours can produce 4 to 6 liters of water in the air per day. And all of that is rising against that ceiling plane, and the air leakage up into that cavity is going to condense on the underside of the decking. I've seen some pretty black and moldy attics lately. Not an ideal situation. So it's, again, severe mold growth should be addressed. Ventilation is a critical component to that, and avoid prolonged exposure to mold. You'll get flu-like symptoms. We used to call it restorator's flu back in the day when we did a lot of leaky condo restoration. I spent 30 years in leaky condo remediation. Now, because of my sensitive overexposure to it, when I walk into a home that has mold, I can tell right away. I get an itchy, scratchy throat and sort of an allergic reaction, an itchiness in the nose, and again, if I stay in that environment, I'm susceptible to getting that what we used to call as restorator's flu, or it's basidiomyte molds within the air that are causing this effect on our mucous membranes. So it's critical to ensure that prolonged wetting is not. That we're not in a scenario of prolonged wetting, because that's what is the food source for fungal growth. Go ahead, Red. I'm probably taking up too much time. Gas safety, combustion. We do a combustion safety test when you have gas appliances under the door, the blower door effect. We provide a combustion spillage test. So I want to find out if I can raise that Pascal limit above 5 to see if you're at risk of combustion spillage. Go ahead, Red. I think we're. So summary conditions, why retrofit your home: to improve comfort, increase energy efficiency, improve indoor air quality, eliminate fossil fuels, and increase the home value. This is very important consideration as we continue to improve. Kootenays adopt energy step code. New metrics going forward means that all new homes are built to 1 air change or less. And you're looking at R50 in your attics, R30 in your walls, and R30 in your foundations. So there will be a massive disparity between new and existing stock as we progress into the future. What triggered my need to do my own home was not just to improve the comfort within, but also to improve the longevity of the building, but also the resale value. I want to protect my investment long into the future. I'm starting with the envelope first approach. I think that's it for slides, Red. Oh, right. So one other critical, I won't read all this because we're going to go through, I've already taken up too much everybody's time. But one thing I want to make note of, most importantly, out of all of this, I've included this literature within the PowerPoint, because this is what is on every renovation upgrade report on the instructions required in order to meet the requirements. So first critical component is ensuring that the components that you are potentially purchasing are on Energuide's searchable database. And what seems to be happening is you're not scrolling all the way to the bottom where it says whether it is a current listing or not. So I just had a scenario, 33 new windows, $40,000+, and only 3 windows qualified under the program because they didn't scroll to the bottom and see that it was a delisted product. One other thing that I'm going to touch on that was that's I think in the next slide, go ahead, Red, is that, it's not on here, but in here are the requirements. CHBA has on their website, it's called Getting It in Writing. It helps understand the contract requirements for a retrofit. So it gives you some guidance on the verbiage and dialogue to be included in that contract. If you're hiring a window contractor, you want to ensure that they meet that the product that they're providing is meeting the requirements, because there's been far too many cases where we get there to do a post and the windows don't qualify. So critical, if you're leaving to your contractor to get that information and make sure it's in writing that they must meet the criterion. So always an excellent resource. if you're doing any negotiation, whether mechanical, envelope, or any of the component of your windows, components of the building, is get it in writing and cover your butts, because nothing like not meeting the requirements to the programs. And I think that's it for me. Thank you so much for my time. You guys have a great night.
Thanks, Jeff. As you can see, Jeff is a wealth of knowledge. You can talk about this subject for hours. As I said, he is the energy advisor currently working with the Retrofit Assist program. So if you go through the Retrofit Assist program, you get the benefit of having Jeff on the case and bring that wealth of knowledge to your home.
Red, I just want to mention to anybody that you're welcome to contact me anytime, as far as a sanity check on a proposal, or whether you're going down the right. There's a free, I offer a free service that you're welcome to contact me anytime for questions or concerns about your current or potential upgrade scenario. So I just want to make sure that's available. There, anybody within Roslyn is welcome to contact me anytime.
Perfect. Thanks, Jeff. All right, I'm going to hand it over to Amber from the Community Energy Association.
Thank you. Hi, everyone. My name is Amber Davis. Thanks for having me here this evening. As mentioned, I work for Community Energy Association, and I'm directly involved with the Retrofit Assist program. So I work on the participant journey side of things with folks in Roslyn, Whistler and Squamish. Next slide, please. So just to give a bit more context about kind of who we are. So Retrofit Assist is one of the many projects facilitated by Community Energy Association. And the project is offered in 5 communities so far. So as I mentioned, Roslyn, Whistler and Squamish. And then we also launched in Kamloops and the East Kootenay region late last year. CEA, we're a BC-based nonprofit that has been working for over 25 years at the community level to reduce emissions, conserve energy, and help transition to a low-carbon, resilient future. Next slide, please. So this is our agenda. What is retrofitting? You probably know by now, but I'm going to tell you anyway. We'll then look at Retrofit Assist, brief overview of the program and participant journey, and then we'll look at a couple of success stories, the challenges faced and lessons learned. Right. So when we're talking about retrofitting, it's the process of modifying an existing building to improve its performance, energy efficiency, or resilience. And as Jeff mentioned, there are many different ways you can retrofit your home. It can include simple energy saving measures, and that can be as easy as switching to a smart thermostat, upgrading appliances to more energy efficient models, or replacing old light bulbs with LEDs. When we're talking about the building envelope, simple improvements can be kind of including air sealing, drafty spots, or adding insulation. Or you could go further and replace your windows and doors with more efficient models. Mechanical systems in the home include heating and cooling, ventilation and hot water systems, and upgrading these systems with more efficient equipment such as heat pumps can be a great way to improve energy efficiency and comfort. And then lastly, renewables. We're mostly talking about installing solar panels, which can be a great way to offset your electricity usage and costs. And solar can also be incorporated with smart EV chargers too. Next slide, please. Again, why do we want to do this? We want to increase our comfort levels in our home. We want to be warm in the winter and cool in the summer. We want to have a healthy home where you're getting fresh air and stale air with toxins are being removed. We hope to see our utility bills reduce, allowing us to save over time. And we will also have reduced our impact on the environment. So Canada's homes and buildings account for around 18% of national greenhouse gas emissions. So retrofitting has a key role to play in reducing this percentage. Okay, next slide. Oh, I don't know why that's black. Sorry, that should be white. So Retrofit Assist, essentially, we're a retrofit concierge program. So the whole purpose of Retrofit Assist is to support you with your retrofits from start to finish. We can help you organise an EnerGuide evaluation with Jeff, help you prioritise which upgrades you want to move forward with, connect you with local qualified contractors, and then also support you through the rebate process as well. So we will support you basically as much or as little as you need to achieve your retrofit goals. Next slide, please. This is our small but mighty team. So starting in the middle at the top, we've got our program manager, Amanda Evans. She's currently on maternity leave. On the left at the top, we've got Mariah Byers, who's kind of our acting program manager. And then we have myself, Elise, and Natasha. Like I said, I work with Rosalind, Whistler, and Squamish participants. Elise works with folks in Kamloops, and then Natasha is focused on folks in the East Kootenay region. Slide. Okay, so I could go on for the homeowner journey for ages. So let me try and squeeze it into kind of a short version. The first step is for a homeowner or renter to apply for the program through our website or over the phone. Once applied, they'll be able to schedule an onboarding call with us, where we'll discuss foundational information such as kind of basic information about their home, their immediate priorities and goals, and their need for support. We then require that the participant proceeds with scheduling an EnerGuide evaluation on their home, and this is just so that the participant and us have all the necessary information about their home in order to make the best retrofit decisions and avoid unintended consequences. From this evaluation, the homeowner then receives a report on the efficiency of their home with a list of recommended upgrades, and we will then work with the homeowner to prioritize said upgrades while considering available rebates and any budget the homeowner may have, before providing them with a list of contractors in their region to reach out to. Once a homeowner has received a quote from a contractor, we'll take the time to review it for them and ensure that their quotes are meeting all the requirements for rebate eligibility. As Jeff mentioned near the end there's a kind of eligible product list that you have to be really careful about. So we do our due diligence to make sure that you're setting yourself up for success and you're not going to be disappointed once you've put in all of that time, effort, and money to not get the rebate in the end. Once you've kind of decided on a quote to proceed with, if you'd like to proceed with our retrofit financing option, this is kind of the stage where you'd apply for and secure this. And then comes the installation, which we take more of a back seat on before coming back to support at the end with rebate applications. So that's a brief summary of what our program does, the participant journey, and kind of all of the different steps that are involved. Obviously, I've kind of slimmed it down, and there's a lot more kind of support that we can offer in between those stages. But yeah, that's a brief summary. So let's look at some case studies from our program. So this homeowner, they came to us wanting to install a heat pump, and the cooling aspect of the heat pump was something that they were very interested in. They were finding that their home was getting very warm in the summer, so they were really looking to improve that. They went ahead with an EnerGuide evaluation on their home, which actually revealed that the basement was the biggest source of heat loss in their home. So you can see in that kind of pie chart on the left there, the basement foundation was responsible for 31% of the heat loss in their home. The image on the right is taken from their renovation upgrade report, so the list of recommended upgrades in the EnerGuide evaluation. And it was kind of apparent that insulating their foundation would kind of save almost as much energy as installing a heat pump, which it's pretty dramatic. And the cost of insulating the foundation would probably be around a quarter of the cost of installing a heat pump. So massive gains to be made there. Next slide, please. So they reached out and got some quotes from the contractors that we provided, and the quotes for the work were coming in between $6,000 and $7,000. The final invoice with the contractor they chose was for $6,600, and they added R24 to their basement box ends, R20 to their basement walls, and the contractor also installed a vapor barrier on the ground. What was the impact of this upgrade? We saw a 39% reduction in energy use. So that's the difference in the kind of energy use between pre-retrofit evaluation and post-retrofit evaluation. Their air leakage rate dropped by 2%. Their carbon pollution dropped by almost 60%, and they gained $3,090 in rebates, which covered around 46% of the cost of the upgrade. So you can see that, a fairly small measure, fairly inexpensive, had a huge effect on their home. And we did a case study, kind of published a case study on these guys recently. And they mentioned kind of going into the winter now that their home is a lot more comfortable, which is fantastic to hear. Okay, next slide, please. So this homeowner, kind of similar story, but a different outcome. So again, came to us just wanting a heat pump. This homeowner, they started with a higher air leakage rate of around 10.5. So as Jeff kind of mentioned earlier, new builds now are typically built with an ACH of kind of 3 or less. And typically from what I see with our participants in Roseland, their homes are typically between 6 and 12. Some folks go as high as 17, which is really concerning. But yeah, most people average between that 6 and 12 region. Why do we want a lower ACH when installing a heat pump? We want to make sure that our home is not as drafty, because it's going to result in a larger kind of unit up front. And ongoing kind of running costs are going to be more expensive because the heat pump's going to have to work harder to replace the heat being lost from the home. So we really encourage this homeowner to perform some building envelope upgrades ahead of their heat pump installation. We also connected them with some of our technical experts that we kind of work with, but they decided to kind of go ahead with the heat pump installation anyway. So you can see in the pie chart at the top, again, basement and foundation and air leakage, the kind of highest causes of heat loss in the home. And you can see from their report, the recommended upgrades, air sealing saving 9 gigajoules a year, still pretty respectable. Insulating the foundation, 63 gigajoules a year. And then the heating system, 113 gigajoules a year could be saved. So I think with those numbers so high, they kind of leaned more towards the heat pump, which is completely fair enough. And, we will support homeowners with their goals kind of regardless. We just want to provide all of the information so that kind of you as a homeowner are empowered to make the best decision for your home. Next slide, please. Okay, so final invoice for the heat pump upgrade was around $24,500. And this homeowner actually qualified for the Clean BC Energy Savings Program, which is a rebate program that offers enhanced rebates for income qualified individuals. So they qualified under Tier 3, which is the more middle income category, which qualified them for a $10,500 rebate for a heat pump installation. And they also accessed the Canada Greener Homes Grant, which was another $5,000 on top of that. So the impact of this one, their energy use reduced by 36%, which is great. Now, we actually saw their air leakage rate go up by 7%. We don't exactly know the reasons why, but it's likely that it's kind of due to inadequate sealing of wall penetrations during the heat pump installation. It is something that we do kind of see relatively often, and definitely something to look out for. Their carbon pollution reduced massively by 94%, which is phenomenal. And that's because they went from, gas heating to all electric. And rebate earned $16,100 in total, which covered around 65% of the cost of the upgrade. Okay, next slide. This one is kind of more multiple upgrades and another income qualified individual. This household, they qualified under the old income qualified program with the province. They kind of refreshed it and made it into the energy savings program. But this household qualified under tier 1, so the lowest income level. They came to us wanting to do a heat pump and windows and doors. And they were kind of struggling to work out how to afford the upfront costs and deposits, even with the different rebate and financing programs that are out there. And it's definitely a considerable challenge for folks. I was speaking with someone today, and their heat pump contractor wanted a 50% deposit upfront. So, that's over $10,000. Again, window and door contractors, if you're getting top tier products to qualify for the rebate programs, depending on how many windows you're doing, you could be looking at thousands of dollars in deposits that you kind of have to pay up front just to kind of get started. So yeah, definitely a challenge for a lot of people. Looking at their Energouge report, you can see on the right at the top there in that pie chart, basement foundation, air leakage, and windows. So they had a few different areas of improvement to choose from, but they felt that windows and the heat pump were kind of the most important upgrades to them. So we supported them with that. Next slide, please. Right. So the total retrofit cost for doing, I think it was 9 windows and adding on a heat pump to an existing high efficiency natural gas furnace was $41.8 thousand. So around $14,000 for the heat pump and almost $28,000 for the windows. It might seem like a really high number, but honestly, that's about right. They used the Canada Greener Homes loan, the Canada Greener Homes grant, and the income qualified program as their sources of kind of rebates and financing. And they achieved a 32% reduction in energy use, 13% reduction in air leakage, an 86% reduction in carbon pollution, and gained about $23,650 in rebates, which covered around 56% of the cost of the upgrade. Okay, next slide, please. So these are just 3 examples of retrofits out of almost 50 people who have now completed their retrofits through our program in Roseland. And what are the most common challenges that homeowners face? First one is costs. Do you have the funds to cover contractor deposits? As I mentioned, they can be very high and can add up very quickly. What are your funding sources? Are you planning on using your savings, a line of credit? Are you wanting to use the federal loan? Are you wanting to go with our retrofit financing? Making sure that you've got your funding sources lined up and you kind of know which parts you want to dip into is very important. Do you have an idea of your budget and the realistic costs of the upgrades you want to do, including any unforeseen costs? We've seen people, and especially in Roseland, we've seen some folks who have gone for window and kind of door replacements, and then rot has been found when they're doing those installations, and it puts the cost of that retrofit installation way up, more than what people could anticipate. So yeah, it's really important. Obviously, we can give you a decent idea of an estimate of what that might come to, or what the general costs are for the different upgrades that you're looking for. But yeah, it's really important to make sure that you have kind of clear expectations of the cost of these different things, and do you have a safety net if these costs go way up? Maximizing your rebates. Windows and doors is probably one of the highest costs of upgrades that I see, and some of the lowest funded retrofits in terms of rebates. So say with the province, the Clean BC program, in the standard program, you can get $100 per window or door up to a maximum of $2,000. And you saw with the previous homeowner in the example there, 9 windows cost them $27,000. So even with the income qualified program and the enhanced rebates, that definitely helped. But had they been in that standard program, they would have got $900 back for that. So there's definitely a cost benefit analysis to be done. How far do you want to go with the work that you're doing? For Windows specifically, if you're starting with single pane, do you want to go to a good double pane window or a triple pane window and go that extra mile? With insulation work, there's also a cost benefit analysis as well. Do you want to hire the contractor, pay the premium of doing the contractor and getting those rebates versus kind of doing it yourself and not getting rebates? There's definitely a good case to be made for, making sure that the job is done well, to make sure that, you're not kind of having any unintended consequences on your home when you're doing these retrofits. But money is a big drive for people. So yeah, it's really important to do that cost benefit analysis, get as many quotes as you can so that you can work out what's the best option for you. Contractor availability, Jeff kind of touched on this a little bit. There are only so many contractors in the region that are qualified for the rebate programs. There's definitely a lot more than there were a few years ago. And another project at CEA works on expanding contractor capacity. But with this limited availability, it can result in longer wait times for the projects you want to do, and difficulty sometimes engaging contractors as demand is very high, and realistically they can kind of pick which jobs they want to do and which interest them the most, unfortunately. Last one, managing larger projects with multiple upgrades. So with larger upgrades, the order of installation and the finer details become a lot more important. So remembering that your home works as that interactive system. So for example, installing new windows and doors, you want to ensure that they are adequately sealed into the building envelope so that there are no gaps in the air barrier. Making sure that penetrations from heat pump installations are adequately sealed. And typically we find that with large projects like this, if there's a general contractor that's acting as a project manager of the whole retrofit, all of the different upgrades, it can help ensure that those finer details are not overlooked, and you're not resulting in kind of a mismatch of different kind of components coming together but not quite fitting properly. Next slide, please. So the main lessons learned, I think we can take away from this. First one, lots of people want heat pumps, but it may not be the best first option. As we can see, I'd say that heat pumps are probably the most common upgrade that people enter our program with. There's a lot of marketing out there for heat pumps. The rebates out there are in favor of heat pumps. There's $10,000 available for heat pumps, but only $100 per window or door. So I think that, that really drives a lot of interest in people. But as we can see from, the first case study that I showed you, there may be other fantastic gains to be made in terms of energy savings and comfort from building envelope upgrades. Second one, every home is unique. This is especially true in Rossland. There's a very wide range in the building stock. Many homes have their own unique quirks and challenges, which may make some upgrades more challenging or even non-viable. Every homeowner is different as well. You have different priorities, different budgets and income levels. So it really is a case-by-case basis. And, at Retrofit Assist, we want to do what is best for you and your home. Don't discount the smaller things. Simple, smaller upgrades can still be effective and not break the bank. You don't have to spend $40,000, $70,000, $120,000 to still have a great improvement on your home and the comfort of your home. And 4, ensure you have the right support. Figuring out the right retrofits for your home, finding the right contractor for the job, and navigating all of the rebates can be really time consuming and challenging and frustrating. So ensuring that you have all of your ducks in a row before proceeding with an installation can save a lot of heartache later. And obviously that's a great time for me to plug Retrofit Assist, because we can provide that support for you and help you right from the beginning all the way to the end. And we'll finish there on the last slide. You can email us at info@retrofitassist.ca or sign up for our program at www.retrofitassist.ca. And if you submit an application form, then we can chat in a bit more detail about your home and your goals, and how we can support you. Thank you so much.
Thanks, Amber. That was great to see the energy assessments and how that paired with the work that people decided to undertake and some of the numbers around those different interventions here in town. This Retrofit Assist program is, as Amber pointed out, quite unique. There's only 5 communities in BC that are getting this offered, and it is quite the service to take advantage of. So yeah, with that, any questions from the crowd for Amber or Jeff? Questions? All right. If I understand correctly, Amber, the current enrollment in the Retrofit Assist means that initial energy advisor assessments are only $100.
That's right, yeah. So they're valued at, I think, $650, $625, something like that. But we've managed to secure substantial funding to be able to offer it to our participants for just $99, which is amazing, and we're really happy to be able to do that. And the post-retrofit evaluations we are able to offer for free right now. So yeah, get in while it's cheap.
Yeah, like when you think about the amount of information and knowledge that Jeff can bring to your home, and then the assistance that Amber and her team can bring to your project, and it's $99 to get that ball rolling for most of our listeners. That's that's an achievable hurdle that is gonna pay dividends.
100%.
Great. Something I just wanted to bring up as well is Jeff used an image of a thermal camera on some buildings. The Sustainability Commission has 2 thermal cameras available for rent or borrow from the library. So for homeowners or contractors, if you want to use those to assess your home, they're a great tool to give you the visual, pre-work and post-work. Which are handy. Something else I wanted to bring up is that the Community Energy Association offers a whole series of different talks and professional development seminars around home systems and energy upgrades. So yeah, if you just go to their website, you can find a list of a bunch of different topics of talks that they have coming up in the next couple of months, and are a great resource to dive deeper into that. And if there's nothing else from anybody, Kristen, anything missed? Questions, comments, feedback, we're always open to hearing them. So don't hesitate. And thank you, Jeff and Amber, for joining us tonight and sharing your knowledge and experience. And thank you for everybody for coming in.
Thanks so much for having me.
Yep. Thanks, everybody. Appreciate the time.
Have a good night.
Thank you. Bye.
Thank you.